In this video, I'm going to go through a past paper question regarding exponential functions. Most of the IB past paper questions have applications with exponential functions, so it's important to understand the basics. If you haven't gone through the basics video, do watch it. So for this question, we have a typical paper 1 style question, and you have a description here. So a population of 200 rabbits was introduced to an island, and after 1 week, so this is the keyword here, so 1 week, the population of the rabbits was 210. So this can be modeled through an exponential function. So it's obvious it's an exponential because you have your variable to the power of t. Your variable is a power, sorry. So your t, which is unknown, the independent variable is a power, where t is the time in weeks. So this is important since the rabbits were introduced to the island. So find the value of b. Now usually they give you the value of b or and such, and they expect you to answer questions based on this. But this time you're meant to find this value that's being raised to the power. And so you'll have to use information from the question. So this information is already there, and then this information is important. So we know that after 1 week, so if t is equal to 1, the number of rabbits, so at 1, is 210. So this information is important. So if you substitute 1, your answer should be 110. So we're gonna have a substitution situation where if I substitute 1 here, it should give me 210. And so we can easily see that you can solve this. So 1 would be a nice number because b to the power of 1 would just be b. So you'd have 200b is equal to 210, and so b is equal to 210 divided by 200, and that will give you 1.05. So your formula or your function is 200 times 1.05 to the power of t. And you can check your answer. Substitute in 0 in here. Make sure they get 200 because initially, if the question said how many rabbits are there initially, you can substitute 0 weeks in here and you're going to get 200, so that's the initial. And if you want to check that 1 week later, so you can substitute the 1 in here and you should get 210. So always check your answers again and again. So any method you get for here, any b, use it later on, even if it's wrong, we'll continue your method. So calculate the number of rabbits on the island after 10 weeks. So they rely on the fact that you found b. Sorry, so instead of t, we're going to substitute 10 weeks. And it's going to be 200 times 1.05 to the power of 10. And this is going to give you 3 to 5.7789. So obviously you can't have that many rabbits. Even if they didn't say, you obviously need to round this. So it's going to be 326 rabbits. So an ecologist estimates the island has enough food to support a maximum population of 1,000 rabbits. Calculate the number of weeks it would take for the rabbit population to reach this maximum. So what we're missing now is t, and we have the number of rabbits. So in our formula, we have this value. We want to see how long would it take to reach 1,000, and this would be as such. Now, the way to solve this for math studies, there's a bit of extra math that you will have to use but not actually understand. And it's not explicitly mentioned in your book, but this method will always be useful and is the most straightforward, fast method to use. What you're going to do is you're going to make sure that you get this variable, this value that's raised to the power on its own. So if there was a plus any value in here, you're going to get rid of that, and then you're going to get rid of the 200. Right now there's not any value being added, so I need to get rid of this 200. So using the balancing method, I'm going to divide by 200, but then I also divide by 200 on both sides. So this way I cancel out my 200, and this will simplify to a 5. Now, if you need to find the value of t, you can't use any straightforward method, and trial and error won't actually work. You're going to take ages to do it. So the best method is to use something called logarithms. And for now, just use it as a fact. So what you're going to do, you can find it in your calculator, and I'm going to show you how. You're going to take, now that we've isolated everything, there's nothing there except for the value to the power, you're going to take log of 5, so whatever you found on the left-hand side, and then you're going to divide it by the log of the base that's being raised to the power, so whatever you're raising to the power. And this will give you the value of t. So in the calculator, this is log over here. So there is a log to the base here, but you don't want a log to the base. You want, so even in the normal scientific calculator, you don't want this situation. You could, in this situation, you could substitute 1.05 here and then 5 in here. So we could try this and then 5 in there. Or what I would just go for is log 5 divided by log 1.05. You'd get the same answer anyways. So this is 32.98, so that's about 33 weeks. So t is equal to 32.999, let's say, so that's about 33 weeks. And you can check your answer. You're going to see that it's approximately 1,000. It's going to be 1,000.6 if you substitute 33. It's going to be 953 if you substitute 32. So 33 is a better estimate here. And that's it, that's final answer. So using logarithms. Just one thing to note, if it was, so example, if it was 200 times 1.05t plus 5, for example, and we wanted to know how long it's going to take to reach 1,000, you're going to have to deal with this first. So you're going to subtract 5 from both sides first. So you end up with 200 times 1.05t is equal to 995. And then you're going to do the whole divide by 200 and then take the log. So the point is just solve it like a normal equation, but get rid of the positive or negative. So remember, we, in the previous video, or in the properties video, we defined all of these as, we define this as k, this as a, and this as c. So you have k, a, x plus c situation. So you want to get rid of c, then you're going to get rid of k. So you want to get a on its own, and then you can take the log. Only then can you take the log. So hopefully this video was useful. More application questions are available. Have a look at them. The book has quite interesting ones, so I am going through as many of them as possible and explaining all the important concepts with exponential functions.